Hi team. You guys are in the matching tables of values and graphs group. So I'm going to show you how that concept works in this video. And I know that some of you have already given it a really good crack, but I can see in your class notebooks that there are some mistakes. So I'm going to go through the concept with you, and hopefully that will help you understand it better. Alrighty, let me share my screen because I've started this recording twice now because I forgot to share my screen in the last time. Alrighty. Okay, so in the class notebook, we are looking at matching tables of values and graphs. So you're learning how to link different representations of linear relationships to each other. Remember, that's the big picture of this topic. The first success criteria is to use your understanding of Cartesian plane coordinates to match a table of values correctly with a graph. So in the previous worksheets, you would have seen how linear relationships can be presented in tables of values, which is this example here, but also graphs. So let's have a look at this exact example here, and then I'll go to another one down the bottom of the worksheet as well. This table of values and the graph are both related. Let me see if I can zoom out. Maybe I'll just go to the OneNote version. Yeah, sweet. Oh yeah, look, I'm waiting for a pizza to be delivered. That's the tabs at the top, which I will close. Alrighty. So this table of values and this graph are connected. The way I know that is I'm going to pick out specific coordinates. So look at this one right in the middle. The x coordinate is 0 and the y coordinate is 0. And look at that in the table of values. When x is 0, y is 0. Let me show you another example. I'm going to use this last coordinate. When x is 3, the coordinate point for y is 6. So when x is 3, y is 6. And I'll show you one more if you're still not convinced. When x is -2, y is -4. What did I say? When x is -2, y is -4. And lo and behold, there's the coordinate point. Alrighty. So like I said, I'm going to jump down to one of these examples here. Now, this is Lincoln's sheet, but that's okay. We can learn from what Lincoln's done already. So match the table of values and the relevant graphs below. I'm going to show you the quick way to do this. The easiest one is to look at where x is 0 and therefore what y is. So in this first one, see where x is 0 here, y is 2. So look at this graph, when x is 0 here, y is 2. And I know that because the line is sitting on that point, on that coordinate point. Righty, and I'll show you another example. When x is 1, y is 3. So x is 1 and y is 3. And there you go. The line is sitting over that point on the Cartesian plane. So that must mean that graph A and the table of values match in this example. But it's not that simple for the other two. I don't believe anyway, unless I made it that simple. Maybe not. Oh yeah, no, I didn't make it that simple. Okay, so when we've got x here is 0, y is 1. So it can't be this graph because when x is 0, y is 0 here. So that must mean it's this table of values, and that's what Link has put down the bottom. And then we also have this last one, when x is 0, y is 1. And see how the line's sitting on that coordinate point? That's the easiest one to pick out, to be honest. Alrighty, now there's more examples. So these ones, the only difference is I've switched the orientation of the table of values. So they're in rows and not columns because it's good to see all representations. Alrighty. So when x is 0 here in this table of values, y is 2. So I'm looking for ones that cross over at 2. So graph D does, but graph E also does. Okay, so we've got to look for another coordinate point. So when x is 1, y is 3. Okay, so that looks like they match up again. When x is 3, y is 5. Okay, when x is 3, y is 5. So that must mean that graph D and this table of values both match each other. Alrighty, so I won't do the whole example for you because that would be too easy for you. You wouldn't learn. But I will jump down to the second question. It says match the equations below to the graphs in question 1. So watch how this works. If I jump back up to the success criteria, to answer question 2, you're going to use your understanding of algebraic substitution to match an equation accurately with a graph. All right, so this is the third type of representation. Remember, there are 3: table of values, a graph, and an equation. So for the first one, I'll do the first one for you. I'm going to think about if I just make up that x is 0 for this equation here, and I substitute 0 into that equation. I don't know, zoom in as well, that might help. That's going to mean, so I'm going to just pretend that x is 0. If x is 0, that must mean y is equal to 2, because 0 plus 2 is just 2. Okay, so then what I can do is have a look at any of the graphs where we've already said when x is 0, y is 2. So there's this one, there's this one, and there's also graph A as well. Okay, so I'm going to check again. When x, let's just pretend that x is 1. So that must mean it's going to be 1 plus 2. Last time I checked, that was 3. Okay, so when x is 1, y is 3. Right, so I'm sensing that graph D here and the first equation in question 2 will be a match. So you can just write D or graph D to answer these questions. Alrighty, so that's how you're going to use substitution to match the equations to the graphs. Alrighty, so I did say there was going to be a quirky question at the end of these videos, which you can now hear and then answer it back in the main call. So the question is, what kind of pizza am I waiting to pick up from the pizza shop? And the answer is a vegan potato pizza, and I'm absolutely starving. So I'm going to race over and pick that up now. But yeah, so the answer is vegan potato pizza. All right, thanks for listening, guys. I'll stop sharing and then stop recording.